Hi folks, how you doing? It's Cliff here again. I've been cylindrically grinding a batch of impact tolerant touch probe arbors and really enjoying that process on my old Brown and Sharp cylindrical grinder. And it's got me thinking about precision and micrometers, and so I've done a bit of a video on those subjects. Different micrometers, precision, metrology, and the pursuit of quality. Alright, I'll get on with it. Well, today I'm grinding the impact tolerant touch probe arbors, cylindrically grinding them. And this is quite a critical process because the accuracy of the probe, the repeatability of the probe, relies on having accurate TTS arbors. And I'm really enjoying getting the arbors ground to very fine tolerances and getting them parallel and to the correct diameter spec, and kissing the TTS flange to give an exact right angle. That generates an exact right angle when you're grinding between centers. And it's a good opportunity for me to talk briefly about micrometers. I mentioned in a previous video that I bought one of these Shahi, is that it? Shahi? Where is it? Yeah, Shahi Chinese micrometers that have quite a good reputation. For many years I've been using my Tessa mic that I bought way back in the 70s, but it has begun to wear, and I replaced it with a Mitutoyo, just a standard Mitutoyo mic, and that's turned out to be really good. I'm using matrix slip gauges to check the calibration of the mics. So a 600 and a 150 gives me a 750, and of course if you've got a slip gauge at the workshop temperature, even though it's cold here in winter, as long as you don't hold either the slip gauge or the micrometer or the part in your hand for too long, then they just reach ambient temperature of the workshop, and everything will be a little bit smaller than it will be in summertime. And this new synthetic grinding fluid that I'm using seems to leave the parts completely dry and clean, and yet I'm not getting any corrosion. So there must be some anti-corrosive chemical remaining on the parts. All the same, I'm going to give it a light spray of Inox tonight, and the slip gauge too, because it's going to chill right off again and I don't want to risk getting any corrosion on it. Well, I won't go into cylindrical grinding too much in this video, but as it refers to micrometers and accuracy and quality, I must say to you American folk, Imperial mic has got a coarser thread and it has a lovely abrupt feel when it registers diameter. Very positive, it's not boggy at all. And the large flanged anvil version is good for measuring down in the undercut zone to check that you have clearance right down to beneath the surface of the TTS flange. In metric it's 19.05 or a hair under is what I'm aiming for, and that's got a nice feel for a metric mic. The TTS flange is ground with the side of the wheel when the part is held between centers, and that generates a very accurate right angle. That's the way that cylinder squares are made, so that the 3/4 inch diameter, if it's parallel and is kissed on the side with the side of the grinding wheel at the same time, gives a very accurate arbor support system. So I found this basic Mitutoyo to be a really nice feel, to have a really nice feel. So this is the mic that I'm using on the cylindrical grinder, where I can reach out through the coolant at an inconvenient distance and get a very quick measurement. I can just place it quickly on the part and with very light thimble pressure read off. I want to be 19.05 and just a couple of microns under, so that it doesn't bind in the TTS collet. That's my decided goal diameter, and you can quickly see that on the machine. This Mitutoyo mic has worn very well. I've been using it for several years now, and it has a nice feel. There must be a good portion of ground thread engagement with it, because it comes to an abrupt stop when you close the thimble on the part, and that's always a sign of a good mic. It's not boggy and varies with different pressures too much. It's a nice abrupt accurate read, 19.047, something like that, just 2 or 3 microns undersize. And I have to admit though that this Shahi is very good, because it goes to microns in decimal place. And here we can really we can check it on the bench each time I check one on the bench, and you can measure it at each end. 19.048, 19.047. So it's 2 or 3 microns under 3/4 of an inch. That's incredibly fine. We're talking about a 1/10 of a thou here. I don't need to reach these sort of tolerances, because the collet will close on a smaller size or a bigger size, but it's fun to work to really fine tolerances and just enjoy the journey of striving closer and closer to perfection. I mean, there's a point where you just start to spend too much time on it, so I don't want to do that. But so here we are. We can check the calibration. We've got to be really careful there's no oil or grease under there. And it's very thermally sensitive. If I hold those slip gauges for too long, 19.05, 0.51, 0.5. This Shahi mic is really good, but it doesn't have the quick feel, and I wouldn't want to use it in the presence of coolant on the machine. Here I can get it very quickly, just an abrupt mechanical stop where the graduations come into line. Cylindrical grinding is a fantastic machining process for very fine and accurate control of hardened steel parts. This is a beautiful old Brown and Sharp, Rhode Island, USA, and I'm a very proud owner of it. Tenth under 3/4 of an inch. That's just what I'm aiming for. That is one high-class machine. Still grinding as good as new. I pulled it apart when I first received it in the 1980s, and every nut and bolt was hardened. Every wearing surface was adjustable for wear and lubricated with oil. Absolute epitome of quality. I still got the original brochure. This machine was built in the 1940s and shipped out to New Zealand for the Pacific War effort. Brown and Sharp #1 universal cylindrical grinder. And while we're talking made in the USA, here's a couple of Starrett mics. Actually, the bottom one's made in America. No, beg your pardon, they're both made in Britain, in Jedburgh, Scotland. But they're Starrett mics, and the original inventor and designer was in the United States. I imagine a lot of you folk do engineering or machining or tool making because you enjoy it. And And I imagine a lot of you have stopped to wonder, why do I enjoy it? What is it about it? What is it about all these little shiny tools and production and the creative process of producing parts that is so enjoyable? And I think partly what it's about is the pursuit of quality. I wanted to touch on briefly in this video the subject of quality and efficiency. I don't want to use the word perfectionism because for some of us the definition of perfectionism is different from others. I mean, some of us think of perfectionism as descending into some sort of compulsive obsessive disorder, and I don't mean that type of striving for quality. I'm talking about the type of striving for quality and efficiency together. And what actually is quality? For example, a Swiss Tessa micrometer. We all know that that has got a reputation for being really high quality, for being the epitome, if you like, of quality. The Japanese and the Swiss have a really good reputation for high quality. I'm sure they have ingrained in a lot of their manufacturers and designers that ethos of striving for higher and higher standards. That's not present in all manufacturers, and probably not all manufacturers in Japan and Switzerland either, but I'm sure it is in the majority of cases. So what is this striving for quality all about? And I think it's an important subject. I can really only touch on it here, but as it relates to us as machinists and engineers, I think if we have an attitude to strive for improvement of process and improvement of end result, of improvement in efficiency and improvement of quality, then, and we keep an open mind, then every day is fresh and a new opportunity to improve, and it keeps the job interesting, and it gives us progressive satisfaction. In order to make continual improvements in our process, in our efficiency and in quality, we have to be prepared to examine what we've done, the end result and the process. We have to be prepared to scrutinize with an open mind and be prepared to admit we haven't got it quite right. And you know, those are not attributes that come easily to human beings. We don't really want to admit that something isn't perfect. It's much easier just to say we've got it right, this is perfect, but it probably isn't perfect, and it can probably be improved and refined. Thanks for watching, guys. Thanks for listening. I'd be keen to get any feedback and comments you have. Please post them. Cheers.